grade 7. So we're going to build on the work that we did last lesson on cuboids, and today we're going to extend volume and surface area from cuboids to all different types of prism. We're also going to look at what makes the prism a prism and how we can use the formulas that we found for the cuboids to help us with the other shapes. So let's just jump straight in. As you can see here, I have summarized the most common way that you'll see the volume and surface area written for a cuboid, and this was the first method for each that we looked at last lesson. Now, these methods that you see here that are the ones which only work for a cuboid. But what we're going to do today is we're going to take those and we're going to pull out the bits that apply to all prisms so we can use them in a more general way. So let's start off with volume. When you think about the volume, it says x times y times z. Basically, multiply all three together. That works perfectly for a cuboid, but not for any other shape. But we can think about that x, y, z, and again, we did talk in more detail about this in the last video. We can also think about that as x times z times y. Imagine we've got this front face here, this rectangle. To work out that rectangle, we would do x times z, because we've got z on the side, x on the top, and then we're multiplying that by the projection in 3D. So the xz is the area of the front, or the cross section, which is what we call it in maths, and we're multiplying that by the depth, the projection in 3D. And again, we did talk about this in more detail in the previous video. Now this is the formula that I want us to use today, because this formula is a bit more general. A cross-section, as we're going to see, doesn't always have to be a rectangle, and every 3D shape or every prism has a depth. So cuboids tell us that if we take the bit on the front that I've coloured in blue and we multiply it by that 3D diagonal depth, it gives us the volume. The cross-section we talked about doing by adding together the front, the side, and the back. So here, xy would be the side, xz would be the front, and yz would be, this would be the side, oops, and xy would be the top. So we talked last lesson about how for a cuboid you've got 6 faces, 2 of each of them, so the front and the back are the same, the top and the bottom are the same, the 2 sides are the same. And again, this formula works perfectly for a cuboid. But we also talked about how we can use a different formula for surface area. If you think about surface area, I'm just going to get rid of this colouring in for a second. Okay. We can also think about looking at the perimeter, i.e. this bit that I've coloured in yellow. This is Z, this is X, and this is Z. So we could first of all work out the perimeter of the cross section. Sorry for looking down at my iPad so much. So here we can see it all the way around, 2 X's and 2 Z's. We already know that the area of the cross section, which we did a second ago, is x times z. If we take this perimeter here and we multiply that by the 3D depth, which is that bit here, then we'd multiply it by y. That would give us the central bit, this bit here and here in the middle. But we'd also need the bits in the front and the back. We'd need 2 of those because there's 2 of each, which is this here. If we were to multiply that out, then that would also give us the surface area of 2xy, 2yz, and that means that we can now use this for any other prism. This here is the depth, is y, times the perimeter of the cross section, And we also need 2 of the area of the cross section, 2 of the bits on the front. So we need all the way round and the front and back. Essentially that first bit here, okay, that you can see me kind of colouring in, is the middle. So it's like the middle plus the front and back. So we're not going to do both of these because it'll take too much time. We'll just do one of them. I'm just showing you a sample question. I'll do the volume for the first one, and then, well, sorry, I do the surface area for the first one, volume for the second. So if we wanted to do the surface area, we'd say, okay, I need to know that perimeter there, which would be 3 plus 5 plus 5 plus 3. So we add them all together, and that gives you 5 plus 3 plus 5 plus 3, which is 16. So the perimeter is 16 centimeters. That's the bit in yellow. I'll highlight it yellow for you. Yep. We need to multiply that by the depth, which is this one here. So we do 7 times that. We also need the front and the back. There's 2 of them, and each one is 5 times 3, because 3 and 5. So it's 15 centimeters squared. And we do that on our calculator, which I'm sure you're all using. 7 16s are 112. Oh, sorry, 107 centimeters, that should be. And 2 15s are 30. So 142 centimeters squared. And that's how we can use that. If we wanted to do the volume, we'd first of all work out this bit here. So we do 9 centimeters times 2.5 centimeters, and then we multiply that by our depth, which is 8. 9 times 2.5 is 22.5. Let me just check that because I like to be thorough. We multiply that by the 8 centimeters, and that gives you a final answer of 180 centimeters cubed. So to summarize, we now know this works for cuboids. We'll check it works for others. Volume is area of cross section times the depth. I'd advise maybe take a screenshot of this in a moment, or just pause the video so you can write this down. And the surface area is 2 times the area of the cross section, the front and the back, plus the perimeter of the cross section. Not right. Times the depth. Notice how you can do them. You can do the area, the cross section, the perimeter, or perimeter area. It doesn't matter which way around you do it, as long as you do those things. So, what makes a prism a prism? I'm using that word a lot. Let's make sure next that we know what that means. Here is an example of a prism. This is a pentagonal prism. Prisms can be any shape. Their name comes from the bit at the front. We can see I've coloured in that bit grey at the front. It's like a pentagon. If I was to colour this bit at the back in, obviously I would colour it perfectly, you can see it's exactly the same shape. A prism basically is you have a front and a back that are exactly the same, or a top and a bottom, basically 2 faces on opposite sides. So like sides, top, oh god, I don't want to do that. Top, sides, front and back, and it's always the same, and they're connected by a length or a depth. Sometimes this is called a length, sometimes it's called a depth. They're kind of interchangeable. As we looked at a second ago, the volume, which we're going to do this one, we're going to do the volume first. We said the volume is the area of the cross-section times the length or depth, doesn't really matter which one we use. So we're going to do the volume first. Here we have a trapezium prism, or a trapezoid prism, or some people just call it a trapezoid. Either way, we're going to work out the volume. To do this, first thing we need to do is work out the area of the cross-section. Hopefully you've all been doing your 2D shape revision that we set last week. There is our cross-section, the trapezium on the front. So we do a little sketch if you want to, you don't have to. I'm just going to do it for you today so you can see. I'm going to work out the area of that shape. We need to know the height, the top, and the bottom. We add the top and the bottom together, divide it by 2, and we times by the height. So it's going to be 10 centimeters divided by 2 times 3 centimeters is 15 centimeters squared. So this shape here is 15 centimeters squared. Now we know that the area of that face at the front is 15. You know that obviously this, if you were to draw the bit at the back, that's also going to be the same thing. So we know we're projecting it in 3D to make a prism. So we just multiply by the 120 centimeters squared. Oh, cubed. Ooh, that was close. So, as with the cuboid, work out the front, multiply it through, and that gives you a volume. And that will work for any different type of prism where it's the same on one side as the other. Okay. Now obviously we could have drawn this prism in a different way. We could have maybe drawn it sitting on itself like this. Ooh, it's not very good prism, is it? Okay. Let's imagine we had this and instead of having it going diagonally, we thought about it in like as a kind of sitting vertically, like so, and it would still be the same formula. That was a terrible drawing, I'm going to rub it away before anyone sees any more of it. Now what about if we wanted to do the surface area? Well, just want to be careful that we don't mix up the formulas. Don't use this one for surface area. Surface area we talked about a second ago. Now you could, we talked about this in the previous video, work out the front, the back, the top, the right, the left, and the bottom. But it's much easier to use the new formula that we've just talked about, which is where we do the perimeter of the cross-section first. So sometimes if you're struggling, I would say start off by writing out your steps. You might see people use CS as an abbreviation. The perimeter of the cross-section, well, this little diagonal is 5, so it's going to be 3 plus the 7 on the bottom and the 5 and the 3. So that's 18 centimeters, and that's the perimeter. Next thing we could do is the area of the cross section. So that's this one here, that's this area. And if you remember, we just did that. That was 15. You can't remember how we did 15, rewind the video. But our formula for the whole thing is 2 times the area of the cross section plus the perimeter of the cross section times the depth, or the length in this case. So let's stick our numbers in. The area was 15, the perimeter is 18, the length is this one here, it's 8. And then all we've got to do, let's use the purple, is type it into the calculator. 2 15s are 30. 18 times 8 is 144. And then we add those together and we get 174 centimeters squared. And that is our answer. And it's much easier to use this formula because you can use it for any prism than it is to start thinking about individual formulae, one for a cuboid, one for a triangle, one for a trapezium. It's easier just to learn one formula that covers everything. And that is this formula here, which I mentioned earlier in the video. We can do this for other types of prism. We've got a triangular prism here. Again, we can see it's got a triangle at the front, a triangle at the back. They're the same. So we would do, let's say, we'll do the surface area, this one in a second. We can see that we also have a prism here, which is kind of an abstract one. We've got like this L shape, but we've also got it again at the back. So as long as it's the same in the front and the back, we can use our formula. Here, let's say I wanted to do the surface area. I'd say, okay, what's my perimeter of the cross section? Well, that's going to be, add them all up, 6 and 4.5 and 7.5. We add those together and we get 18. Oh, 18 again. We could do the area of the cross section, which would be the base times the height divided by 2 for our revision. So it's going to be 13.5. Let me just check that while I'm a bit concerned. I don't want to make a mistake on the video because then you can all see it forever. Ooh. Yep, 13.5, I was right. And then we can use our formula. We say 2 times the area of the cross section plus the perimeter of the cross section times the depth, that's this one here. Ooh, running out of space. And then we do that, so it gives us 27 is the front and back. 18 times 12, 180, 36, 216. And we add those together, 243 centimeters squared. We could also have done, oh, let's make a copy of that page. Let's do the volume of the L shape, shall we? I thought I might fit it on one page, but I didn't. Let's just, let's do the volume of this one. Volume is always a little bit quicker. First thing we need to do is work out the area of this bit here. Sometimes with these shapes, it might help you to do a little sketch so that you can visualize it a bit easier. Just a nice quick sketch. We can see it's 2 by 2 here. This is 4, this is 2. And we don't know the whole base, but we know that it's 2 and 2. That must be 4. 2 and 4, that must be 6. Split it up into little parts. This one here is 6 and 2, which makes 12. 2 and 2 makes 4. So the area of the cross section is 16. And then we take that 16, and all we need to do now is multiply it by the depth. And that's going to give us 16 times 7 is 112 centimeters cubed. So even for a non-normal shape, like a compound shape like this one with an L, you work out the area of the L and then times it by the depth. The volume is always the same, area times depth. The one you'll probably have the most difficulty with is cylinders. Please remember that cylinders are also prisms because we've got a bit at the bottom, bit at the top, and a bit at the bottom, and they're the same. Also notice this one was like front and back the same. We can also have it top and bottom the same, and that's the same thing. The cross section is the bit that's the same. So here our cross section is the circle. Okay, so even though it's not the front, it's still the cross section because it's the same twice. We can work out the area of the cross section. For a circle, if you remember, the area is pi times radius squared. We did that in our revision last week. The radius here would be halfway, so it's just 3. That'd be pi times 3 squared, which is 9 pi. A little bit of advice, if you leave it as pi, it will make your calculations much easier than using the decimal, which would be like 28.2743 and blah, 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 blah. I would strongly suggest that you leave it in pi, and you'll see why in a minute. We can do the circumference, which of course is the circle word for perimeter. Circumference was pi times diameter, or 2 pi radius. Oh dear, don't want screensaver. What are you doing? So here the diameter is 6, so pi times 6, which is just 6 pi centimeters. This is 9 pi centimeters squared. We're going to keep it as this one here. You'll see why again in a moment. We want to do the volume first. Volume's a more straightforward one. We know it's the area of the cross-section times the depth. So it's going to be 9 pi times the depth. Now the depth is the distance between the two, the top and the bottom here, or the front and the back. So it's 8 centimeters. That's centimeters squared. 9 times 8 is 72, and we add the pi, centimeters cubed. And as you can see, if you leave it in pi, it gives you a nice whole number. Okay, you could have done that as a decimal, 72 pi, which would have been 226.1946, blah, blah, blah. Leave it in pi, it's much easier, but if you do want it as a decimal, you can get the calculator to do it for you, 226, do it to 2 decimal places with a unit. So there's your volume. We can also do let's see what would have happened. Keep the same information. Notice we use the same information for volume and surface area. If we wanted to do the surface area, or SA, we do 2 times the area of the cross-section plus the perimeter of the cross-section times the depth. Again, keep it in pi, makes it quicker to type into the calculator. 2 times the area was 9 pi centimeters squared. The perimeter was 6 pi. The depth was 8 centimeters. And then you do that on the calculator, it gives you 18 pi plus 48 pi, which is 66 pi centimeters squared. Although you can do that on the calculator and it will give you a decimal. Do it to 2 decimal places and that would give you 20. Reading it off, 7.35 centimeters squared. So again, we're using the same old formula, which is this one here. Any prism, whether it's circles or whether it's trapeziums, L shapes, triangles, rectangles, it's always the same formula. I'm not going to go through this one because, or maybe I will in a second. I might come back to this in a minute. But you can see there's other types of prisms. There's weird types of prisms, like prisms with a bit cut out. And again, same formulas apply. I'm going to come back to that one in a minute. I just want to jump forward to a summary of what we've done so far. Okay, these two formulas, as we can see, are the same for all different types of prism. Area of the cross-section times the depth, area of the cross-section, perimeter of the cross-section. It's all about the cross-section. Okay, if we go back to that cylinder question we just did, okay, always a good idea to work out both of them. You can, circumference means perimeter, so we can use those. So if you're feeling a little confused, you might want to stop and have a go at the first set of questions, which are on fully solids using these formula here. And if you are pretty happy with this, I'm just going to show you another little thing you can do with that more complex question to save yourself even more time. So, volume of the solid part of the pipe, which is this bit here. And we can see that it's kind of repeated twice, so it's still a prism. And there's a hole in the middle. Yep. So, drawing ourselves a little sketch, we've got a big circle, and we've got a little circle inside. And we're looking at the area in between. So the large circle, and again, we're going to leave our answer in terms of pi. The area of this is going to be, well, it says the diameter is 50, so that means that the radius is 25. It's going to be pi 25 squared. So again, we're going to leave it in terms of pi. Oh, don't do that. Lock the rotation. Do not rotate. And that gives you 625 pi centimeters squared. The smaller circle, or the inner circle, is going to be half of 30, so it's going to be 15, so it's going to be pi 15 squared, which is 225. I'm worried now that I don't know about the square numbers, but I do. 225 pi centimeters squared. And therefore the shaded part, the grey shaded bit, that's this bit here. The grey is going to be the larger minus the smaller, so it's going to be 625 pi minus 225 pi squared, and that will give you 400 pi centimeters squared. The question also tells us the diameter, the length is 2 meters. That means the distance here. So we now know the area of the grey is 400. So all you need to do is say, well, that's 2 meters or 200 centimeters. So we take the grey cross section and we multiply it by the 200 centimeter depth. And remember that we're giving our answer in terms of pi. 400 times 200 is 80,000. So that's pi centimeters cubed. That is perfectly fine to leave your answer like that. If it asks you to write it as a decimal, then you'd have to write the whole long, boring decimal, which would be 2,5,1,3,2,7, 2 decimal places for 1 centimeters cubed. So even with a question like this, you can still use the same formula, the cross section times the depth. Last thing we can do. Now this question didn't ask for it, but I'm going to show you with the surface area. Here's a neat little trick you can use for when you have shapes with holes cut out of them. What you can do is think about the perimeter. Perimeter is everything on the outside, but when you cut a hole out, it's like exposed to the world. So we've got this outside perimeter, sure, which is that bit there. But you've also got the inside perimeter. So the perimeter will be the outer circle circumference and the inner circumference. So we add those together. The outer one is going to be the diameter times pi. The inner one is the diameter times pi. So the total outer perimeter or circumference is 80 pi. We know from before that the area is 400. So we can say the area is 400 pi, because we did that before. So we can use our big long formula. We can do 2 times the area of the cross section plus the perimeter, no bracket there yet, times the depth. So we can do 2 lots of the area, 400 pi. We put the unit in at the end. And then we can add on the perimeter, which was 80 pi, because it's the inner and the outer. The depth we know, we did it before, is 200 centimeters. It's that there. And I'll have to move all of this up because I'm running out of space. So we would say 2 times 400 is 800 pi, plus 80 times 200 is going to be 16000 pi, because there's a lot of space in the middle. And that gives us 16800 pi centimeters squared. And again, you can type that into your calculator if you want it as a decimal. So we can still use the same formula, we just have to be a little bit clever, and we can think about it as the inner and the outer as the perimeter. So essentially that and that is the perimeter. And we can then use the same formula as normal. So that was a long video. If you made it this far, well done. Good job. And as always, please feel free to go back and review any of the stuff that we've done. Just remember that these are the key formulae, and you can use them for any prism, and a prism is anything that's the same front and back, or as we saw with the cylinder, top and bottom can also be cross sections, front and back, because you could have drawn this, of course, as a shape like this. Oh, that's not a circle. Yeah. You can draw, it's a terrible cylinder, but you get the idea. Okay, front and back, top and bottom, doesn't really matter. Okay, it's still the cross section because it's the same on the front and the back. And the depth or the length is always the distance in between. So I'll go right back to the final thing, leave it on that as a summary, think about that, nope, don't want to undo, and give that a go. Enjoy!